And let me show this integral by 4 methods. Now this integration is not easy, quite complicated. So let me go slowly now with the 4 methods. This example would be very good for those who taken basic calculus course, to improve the using basic techniques of integration. Now, before we doing this integral, let me show how to get this basic integral. We will use this one in our solution. Now, to solve this one, obviously we let x be a tangent theta. So inside becomes a square secant square. And then square again becomes a fourth secant fourth theta. Now dx is a secant square theta d theta, right? Then the simplified becomes this. This integral is easy. This is half 1 plus cosine 2 theta. Then integral becomes this. Well, I just omit some details. You can fill up by yourself. Then we use triangle to convert x, right? Tangent theta is x over a, so x over a is tangent theta. So this hypotenuse is this. Then sine 2 theta is 2 sine theta cosine theta. So cancel with the half, becomes this. Now theta is arctangent x over a. That's okay. Sine theta is this over that. Cosine theta is this over that. Then it becomes this. So finally we get this is the result of that integral. So we will use it in our solutions today. So this integral is this. Okay, let's start our today's integral. Okay, now for this integral, I let the first method, this is the first method, let t be tangent x. Then x is arctangent t. Then we differentiate both sides. If we differentiate both sides, we get dx is this. Right. And also that from this assumption, we have a triangle. Tangent x is t. Tangent x is t over 1. This is our hypotenuse. Now then, we plug this assumption into our integral. Dx is this. See? Dx is this, right? Sine square x is this. This over this is square. Cosine square x is this over that square. Okay? So we plug those into our target integral. We have this. Then from this, if I draw 1 over 1 plus tangent square out of the bracket, and inside bracket will be this, right? After square, it becomes this square. This 1 over this is square. Then cancel with that one, we get x t squared plus 1. So in other words, we simplify this one, we become this. That's exactly the formula. You see, need. No, not yet. t squared plus 1 become t squared minus plus 2 plus 1. And this over this is this. This over that is this. This integral is easy. This integral, I think you can do it. Now it becomes arctangent, right? This integral is, I just developed this formula, right? This integral, like this, a is a root 2. Then I copy the result. So this becomes this. A is root 2. Okay, let me see that. This integral is like this. A is root 2. The result of this. Then we plug everything to this formula. We get this. Then this and this are like terms. We can put them together, become this. And this time this one is this. So finally we put t back. We put t back. T is what? T is a tangent x. So we get the final answer by method 1. Okay, this is method 1. Method 2. Method 2. We use the method 1's beginning. We use this assumption, and until we reach this. So method 2 is a method that starts from here. Okay, start from here. Let me copy this one here. So method 2 is start from here. See, let me show that. This is a method 1. We start from here. We consider as a method 2. Okay. We know that assumption is x is arctangent t and t is tangent x. And then we start from here. We are using second method. Now here I take t out. Take t out. It becomes t plus 1 over 2 over t. Then this t becomes, after square is this. Okay. Then we divide by t squared to the numerator. It becomes 1 plus 1 over t squared. All right. So this is our integral after we simplify, right? Here. Now, here, well, the denominator, this is denominator. This denominator after, spend that binomial is this. If this is negative, then this is this. This will be this. And the difference between these two is 8. If we add this one by 8, we'll go back to this one. This one is this. This one plus 8 will be this. In other words, this is same thing as this. Okay. This plus 8 is equal to this. So in other words, our denominator could be written as this or that. Now, secondly, the numerator is this, right? is this. This numerator I want to split into two of this one and that one. A number times this one plus another number times this one is this, which is possible. We can solve the equation very easily by for AB. Now A is this, B is this. In another word, this numerator could be written as 3/4 of this plus 1/4 of that. See, this becomes 3/4 of this plus 1/4 of that. Okay, the denominator is this, right? Now then, for this one, I can write dt minus t2 over t. This derivative is this. This derivative is that. And this denominator I could write this way or that way, right? For this numerator, I write this because the same variable. For this denominator, I write this because they are same variable. No? I can bring same variable. So therefore, this integral is this. See, I just omitted the detail. You can fill up the details yourself. This integral is arctangent. This over this, right? Square. And this integral is like this. Well, I write this one like this, right? D star over square is equal to -1 star, right? D star over star square is this. So it becomes -1 over that. Then I plug a t back. T is tangent x. Then this tangent x, this tangent x, this tangent x. This, you multiply t squared plus 2 on t, right? So this becomes this after replace t by tangent x. So this is the result. This is the result of the integral by method 2. Okay. Method 3. Well, method 3. I write the numerator is 1, right? 1 is sine square plus cosine square. This is sine square plus cosine. This is 1. This is sine square plus cosine square is 1. Now the reason I put this because I can simplify, right? This over that is this. After cancel this and with this, right? This over that is this. Okay. This over this is this. This over that is this. Then I multiply by secant square both numerator and the denominator. Secant square times the x is this. Secant square times this one is tangent square. Secant square times this one is 2. And similarly, here I multiply by 1 over cosine fourth for numerator. It becomes this. Because this one times this one is 1 over cosine square, which is a secant square. For this, 1 over cosine fourth times this, it becomes this. Because this goes in square root becomes square, and sine square over cosine square is this. Cosine square 2 times over cosine is 2. So let me repeat again. I multiply by 1 over cosine fourth over 1 times cosine fourth. It becomes this. And then this one is, I change the secant square dx is d tangent. I change it, secant square dx is this. Now, for this is very easy, arctangent. You can finish it by yourself. For this one is my formula, right? This one. This integral is this. This integral is this. I did it in the beginning. So this, same thing as this, right? X is tangent x. A squared is 2. So I use the formula. I use this one for this result. And I get this. Well, I think you can see it in the previous part of the video. So this integral becomes this by using the formula I did in the beginning. Then this and that one, they are like terms. You put them together, become this. This time this one is this. Okay, so eventually you get the result. This is method 3. Now method 4. Method 4. Now method 4 is this. The derivative of the denominator, this one, no square, denominator, this one becomes 2, this derivative is this derivative is this, right? And the dx, there's no room for dx. Then I simplify this one and this one added up become negative 2 sine x cosine x dx. And this one could be written as negative sine 2x. So this one is this. So if I write denominator as this one, well, divided by sine 2x, this is equal to dx, right? The same thing. Let me put it this way. I write this one on top of the denominator, right? As a denominator, which means to balance it, I divide it by negative sine 2x, I get equal sign back, right? So this one is equal to this. After consider this situation. It's negative, huh? Then the integral becomes this. This is this, right? No, d1 over star is negative 1 over stars, right? Okay, then d star. This is this. Negative, huh? This is square. Square here. This is this, right? So this is this, negative. cancel negative, become positive. Okay, d star over star square. D star over star square is d 1 over star negative. That's what I mean. D star over the star square is negative d 1 over star. So d star over star square is a negative. Cancel that one, becomes 1 over that. See? Then by parts, this is u, this is dv. U dv. U dv becomes a v uv. This time this one, this is uv. Minus v du. V is this, 1 over that. Du is the derivative of this. That's du. Then this is this, right? I'm not touching it. And this derivative is by quotient rule, right? This is square. This is 2 sine x cosine square. And negative become positive. This negative become positive. The derivative of this one is 2 cosine 2x. 2 cosine 2x. This is cosine 2x dx. Then I'm consider this integral as a j. J is this integral. This is 2, this is 4. The 2 square becomes half. So j is this integral. Now this integral 2 over 4 is half. This over this, I cancel cosine square, right? This is cosine square, sine square. This over that is this. This over this, cancel sine square, becomes this. So this integral becomes 2. 2 integrals. This over this minus this over that. Then, well, then 1 over sine square is the cosecant square, right? 1, I write this, 1 becomes this. 1 over sine square becomes this. Similarly, that 1 is this, 1 over cosine square is secant square. Then this one is the d cotangent, negative. Cotangent derivative is the negative secant square. And here I'm divided by sine square, both top and the bottom. This becomes 1, this becomes cotangent square. This becomes 1, this is cotangent square. Similarly, secant square is d-tangent. And here and there I divide by both by cosine square. Become tangent square and 1, tangent square and 2. And then 1 plus cotangent square becomes 1/2, 1 plus 1, 2 cotangent square. So half becomes 1/4. And here, this one becomes tangent square plus 2 minus 1. See the reason of doing this, because this one over this one becomes 1. This one over this one becomes 1. Right? So This over this one becomes 1. 1 times d cotangent becomes this. 1 over this is 1 over this times d cotangent is this. This over this one is 1. 1 times d tangent is this. And d tangent x over this is this. So this integral is this. This integral is arctangent. G like this. I change 2 cotangent square becomes root 2 cotangent together square. And d cotangent becomes d root 2 cotangent times 1 over root 2. So this one is arctangent. Okay. And this one is tangent. This one is using formula or using integral arctangent. You get this one. So this becomes my j. Now my integral is this plus j. This plus j. So end up with this one plus j. J is the whole stuff. And then this plus the whole thing becomes our result for the integral by fourth method. There's so much details to well, I hope you can fill up with the details now, and everything is written here. So I hope you're not lost. I hope you like it.